everybody. Woohoo! Woo! Feel that excitement, people.
Alex, did you stuck in Ireland where you cannot shave your beard?
Yes. I've had to go hunting for pieces of flint. There's no technology here.
Yes.
Anything I can get Wi-Fi. Well, I figured I would go for the Father Christmas look, you know, for Christmas, and then I just forgot to shave again. I'm going to look like a real old graybeard Unix hacker soon.
Yes.
Okay, I guess it's the top of the hour. Well, no, still a few seconds left, I think. Okay, my computer clock said it's 2 p.m. CET now. So welcome everybody to our first Engineering All Hands of 2021. Let's hope it goes a little smoother than 2020, eh? World-wise, Jina-wise went perfectly well last year. Okay, so quick intro for everyone new here. What is Engineering All Hands? It's our community call. We talk to the community. It's open to everyone. It's a summary of what we're doing, what we're striving towards. Our engineers do a bit of a show and tell, and it's a forum for you to ask any questions you have about technical or product or whatever. It's second Tuesday of every month, 2 p.m. to 3:30. It's right here on Zoom. Yeah, in terms of upcoming events, we don't have much on the calendar except the biggest thing ever, which is our 1.0 release coming up next month. So we've cleared the decks for that. If you want to find out more about our upcoming events, check the link below, JinaAI/events, or follow us on LinkedIn, Twitter, or whatever social network you use. I don't know why that's here immediately, but yeah, we're going to start off by talking about JinaD. So I will stop sharing my screen now and hand it over to whoever is presenting this bit.
Okay, yeah. Hey, this is Nan here. I would like to take the host.
You can already present. It's like a multi-host presenting.
Yeah. Share screen. Okay. So can you guys see my screen?
Yes.
Yep.
Okay, great.
Bright and clear.
Yeah. Okay. Yeah. So hello everyone. Welcome to the first all hands. Yeah. First of all, wish you all have a very splendid beginning of the new year. So today I would like to talk about JinaD. So some of you might have already heard about JinaD previously, because this is firstly introduced together with Jina 0.8 back in last November. So JinaD is short for Jina Demo. And as the name implies, it is a daemon process for Jina. So specifically, JinaD is a process for deploying Jina flow, pods, and event-piece on the remote machines. This is especially used for when you want to deploy Jina on a remote machine, or maybe you want to have some parts of your flow running on the remote machine. Maybe I can open the playback mode. Well, looks nicer. Okay, great. Yeah, so here I give an example. In this case, you create your flow, your Jina flow locally, and under the hood, this flow consists of 3 pods. So one gateway pod and one pod running in a local process, and another pod that the core part is actually running on a remote machine. if you look into this remote pod, it actually when you create this remote pod, it's actually will call the JinaD process running on the remote machine, and the JinaD will help you create another pod on the remote machine. So this remote pod running on the remote machine will do the real job, and then it will send back the message back to your local machine. Yeah, let's go into details of JinaD. So first of all, you need to install JinaD on the remote machine. As we have seen on last slides, on the remote machine, if you want to have if you want to create your pod or flow on the remote machine, it is necessary to have JinaD installed on your remote machine. That we offer two ways to install JinaD on the remote machine. First of all, option one would be you can directly run it with your Docker with the Docker image we offered. Option two is that you can install via pip. But we recommend you to use the option one because JinaD actually have dependencies on FluentD. FluentD is a log management package framework, and we actually rely on FluentD to collect logs from different remote machines. Yeah, so if you choose PyPy installation, then you will need to install FluentD by yourself. If you choose the in the Docker image we offered, we already include everything. You don't have to worry about FluentD. Yeah. After so here I've already listed the command for starting the Docker image. Here we use -d to keep the Docker container running in the background, and we set the network mode to host so that we expose all the port. We expose all the port of the Docker container to the host machine, because Jina will heavily use different local port. Yeah. Okay. Yeah, let's give it a try. Now I'm on my AWS machine. Oops. Okay, seems frozen.
I think because you use VPN and then the last connection is broken because of
yeah, yeah, I guess so. Let me. Well, it's a rush hour for me, so the network is a bit slow. Yeah, so let's start rock. So as we said before, we use the -d to keep it running in the background. The network mode we choose to host. And we use the Docker image Jina with the label latest demo. Now we already have our Docker container running in the background. we use with the Docker logs to check the output of the container. Yeah, C is running. And we can also check the running status in your browser. Here, our IP address is, I think I already have it, 3. Yeah. So this is your IP address of the remote machine. And by default, we open the 8000 port. And then, because we are using the fast API, that's why all the docs about the API are listed here. And you can also check the liveness via the alive API. Yeah. Now we already have the JinaD running on the remote machine. Yeah. The next one, if you want to run next step, we are going to run our to create a pod on the remote machine. The simplest way would be using Jina pod command line. And here you need to specify which the remote host you want to use and the pod that JinaD expose. Yeah, since we are using the default settings, it's 8000. And uses, you just specify which, you just specify the config files of your pod. Here we say uses underscore log forward. It's using the default default resources file of Jina. Yeah. If you run this command, then what's happening is something showing up here. So on your local machine, you will have a kind of wrapper pod running in the process. And this remote pod will call. When you run this command line, then this pod will be created in a local process. Then it will call JinaD on the remote machine. The JinaD will create a local pod on the remote machine and connect it back to the remote machine on your local machine. Yeah, this is something really trivial. And what is more interesting for you guys might be we can have a flow running locally. And then in this flow, we can have one pod running locally and another pod running on the remote machine. So this is basically what we have introduced. This is really a common use case for JinaD. For example, when you have a flow running on your local machine, and for the encoding part, it's really computing expensive, then it's better to put this pod running on the remote machine. In this case, you can directly say, for the encoder part, I can run it on AWS or whatever you have the powerful GPU computing resources. Yeah, let's try this code. Oh. Yeah, I prepared the code beforehand. Yeah, so some explanation about the code. So basically, we create a flow and we add. So we add one pod using the forward configuration. So basically, it will receive the message and just forward the message to the next pod. In the next pod, we use the same configuration, but we set the host. Say it will be running on the remote machine, and for the remote machine, the JinaD for the remote machine, the JinaD port will be 8000. Then we build the flow and index 2 lines, say hello Jina. Yeah, now you can run this script. As you can see, here, we create a remote port with the ID 2985. And then let's check the back. On the remote machine, well, we will print, seems there are some delay here. My network doesn't function. Oh, sorry, the VPN seems broken again. Guess room. Let's do it again. Well, yeah, seems a rush hour for network. Can you guys still see it? Am I still audible?
Yes, we can see that.
Yes.
Yeah.
But it's frozen.
Yeah. Probably
Yeah, okay.
next time you can
Is,
you can use Tencent Cloud or Ali Cloud if you want to showcase
Yes.
inside China. Yeah.
Yeah. Okay. Well, anyway, so when you run this script, you will see on the remote machine, it will print out the same message. Okay, maybe you can check again. Okay.
You can do -F.
It's just like, well, yeah, my terminal is really like popping. Yeah, as you can see here on the remote machine, it will print the same message. Say already you start a pod with exactly the same ID.
But does the message? I don't see the message printing as see. I see the part is starting, but the message is not printing on that part.
You mean locally or remotely?
IDE, right? If you go back to PyCharm,
yeah.
I think the PyCharm also starts there. Right? So the second part.
I guess so. I'm not sure whether it's because of my network or the VPN. Yeah, so you're right. It should print out the logs for the second pod.
Yeah, so basically right now it seems that the pod is successfully started, but it doesn't receive any commands or any data from our local flow. Yeah, but we have to check that. Yeah.
Yeah. No. Yeah, the network got really crashed for me. Okay. Yeah. So anyhow, you guys already seen that how to use JinaD to run a pod on the remote machine and still keep the flow running on your local. Yeah. So beyond that, you can also use the JinaD to run the whole flow on the remote machine. So basically, it's the same paradigm like before. The difference is we are now having the flow running on another remote machine, and locally you can use the client. We have the Pi client, so you can locally you can use the client to call the flow on the remote machine to do all this indexing and query. For this one, I won't show you the demo, the live demo, and we've already provided an examples in our examples repository. So this example is using the Docker composer, so that you don't have to worry about the remote instance. You can we will send the link later, so you can check out the examples. In that examples, what it is doing is basically you can you from your local machine you upload all the flow configurations to the remote the remote machine which you want to run your flow, and then you can call the remote machine to create the flow. Afterwards, you can use the client to do indexing and query as you want. Yeah. So that's all the introduction about Jina Flow. About the JinaD. Yeah. And you can use JinaD to deploy and managing all your Jina flows and pods on the remote machine. This is really important for us because as some of one still remember that Jina, the slogan of Jina is to enable people build. The slogan to Jina is an either way to build neural search on the cloud, and Jina is born to be working on a distributed system, and JinaD is then really important part for running Jina in a distributed way. Yep, that's all from my part. And I will hand over the host to Cristian.
Hello. I will share my screen now. Can everybody hear me and see my screen?
Yes.
Is your video on as well, so we can see your lovely face?
I can hear you crystal clear with your amazing setup.
Thank you. Yes. So I'm going to present a bit about CRUD, the features that we implemented, and some of the limitations that we are facing. And I will also provide a short demo. So like a short overview, what is CRUD? CRUD stands for create, read, update, delete. And these are the classic operations on a database. And so far, Jina only had the first two, create and read. In order to do the other two, you would have to rebuild the index. But now we support update and delete operations on all the indexers and drivers, both vector and key value based indexers and drivers. In order to do this, we had to do a couple of changes. One of them, the one that will probably be the most obvious for users, is that the document ID is now independent of content, and it can be assigned to whatever value you want. There are some restrictions, but basically you can set the ID yourself. But before, the ID was based on a hash of the content of a document. We did this, and then we discovered that we can now cache by both ID and content hash, which allows you to avoid duplicating documents of the same content or of the same ID. Um, and uh, now I'm going to show you a short so these are kind of like a basic overview of the changes that we've implemented, but there are a lot of like smaller things that we will provide in the more detailed documentations when we release the new version 1.0. So without any further ado, I'll post a link to the code. It's part of our, it's already released. There are parts of CRUD that are released, but they're not yet stable, or there are a couple of inconsistencies that we're still working on to iron out bugs and improve documentation. But for example, you can look in the integration test for basic CRUD and you can follow along. I will now switch to PyCharm. I will increase the font. Let me know when it's easily readable. Is it good now?
Looking good.
Okay. So.
Can everyone else see that okay?
Yes.
Yes.
Cool. So we have here an integration test for CRUD. Let's first look at the flow. That's one of the most interesting parts. So the flow itself is simple, but the indexer pod is where the magic happens, so to speak. So here, we don't have anything special in terms of the components. They are just a NumPy indexer, which is a vector indexer, and a binary PP indexer, which is a key value indexer that we provide as part of the Jina core. But then the magic part is here. Depending on the request type, you will need to provide these sort of configurations where you specify the method and the executor. So for example, for the update request, we will use a vector index driver with the update method on the vector indexer, which is the name from here. So that's what you need to look out for. And the same for the key value index driver, we provide the update method, and then you reference the executor by name, the one from above, this one. An important note, the traversal paths, you need to make sure that you're using this correctly. At the moment, we are using the R mode, which means that we only traverse the documents themselves and not their chunks or their matches. If you want to traverse those as well, you need to add the specific configuration here, like so, for example. There will be more examples of how you will do this in Jina. We're still working on them, but just as a note that this is really up to your own custom case, so you need to make sure that you configure them correctly. So that was the update request, and for the delete request, it's quite similar. You need to specify the method, then the executor, and again the traversal path. And then the index request is the same old indent request from before, and the search request is the same one. So these two are the new ones. Now let's go back to the actual code. The first method that we'll look at is delete. So here, let's ignore this part for now, and let's just look at loading the flow. We're loading the flow from this file, and then we're adding some documents. When we create these documents, they get assigned specific IDs from this function that we have here. We see that it's assigned based on the position it has in the list or in the generator. So they will be distinct IDs. And then we validate the size of the indexers. Because we generated 10 documents, it should be 10. And that's all fine and dandy. And then we search with, we're generating again some new documents up to number of searches, which is 5. So we're generating 5 documents with IDs, with 5 distinctive IDs. And then we validate the result that we get back. And this is where we come back to the function, this one. So Jina, upon search, you need to specify the output function, and that will take the results from the search and process them in whatever way you need to process them. In our case, we're just validating that the number of matches is the one we expect. So we're passing here top K, which is set here at the top, it's 9. We're passing top K, and we're just validating that each document that we send as a request, which are these 5 ones from number of searches, remember that, they have the number of matches. And that's the classic, there's nothing new so far, but just to get on the same page. And then we can delete the documents. And remember that I said that they each have distinctive IDs. So when we delete by IDs. So these documents here from 0 to 10 will be the same documents in terms of IDs as these ones over here. So when we delete them, we delete all the documents we have basically. And then we can look at the index size again, and we'll see that it is 0. This function will validate that. And finally, we can also do a search to have the same sanity check, validate result that we have 0 matches. And when we get to this function, so number of matches is 0. We will have 0 matches because there are no documents in the indexers. And that was the delete method. Now, I'm going to show you a quick example with the update. This is a bit more complex, but it's not too hard. Again, we index some documents, then we search some documents, and we validate the content in this case. Because we're looking at an update operation, we're looking to make sure that the content has been updated. And we have this parameter now to the validate result function has changed false, meaning this is the validation before the update. And when we look at this function, if we have has changed is false, it means that we will look at the hash contents from before the update, which are based on these documents. So docs before and then docs updated. Now, we've done that, we've indexed, we've searched, we've asserted that it's the content from before, and now we perform the update. It's as easy as calling update, providing the document we want to update as the input function. And remember, we're updating by the ID of the documents. So in this case, the results of this function will give you back documents that have a specific distinct ID, and they will be shared. So the documents in this list have the same IDs as the documents in this list, even though their content and the content hash is different. So we've updated, we validate the size. It's still 10. We don't add, we update. And then when we search, we provide this has changed equals true flag, meaning when we look at the content of the document matches, we need to make sure that it's the document it's the content of the documents after the update. And again, that's done in here on this test, and it passes when we run this test. And that's it. That's the simplest way to do delete and an update in a flow in Jina. And again, there are more complex cases, and we will document them and add examples for you to look at and base your own use cases on. However, there are still some limitations, and this is the next part. Firstly, partial updates are not supported. So if you have a document, say, and you update a specific tag in that document, let's say you have a tag of author and the document is text of a lyrics, of a song from a lyrics, for example, and you actually realize that the author was wrong, you want to update that. Well, you can't just perform an update on a specific tag, unfortunately. You have to send the entire document again with the corrected tag. Secondly, chunks are not updated. Chunks need to first be deleted and then reinserted with the new data. If you don't, the old chunks will still be there. As an example of this, think again of the lyrics. Maybe you realize that one of the lyrics was wrong in this bigger document and you correct it. And then in order to make sure that the old chunks are not still there, you need to delete them manually, get their IDs, delete them manually, and then insert the new document with the corrected text, and the new chunks will be automatically processed and added to the indexers. Thirdly, when you use more advanced indexers like FICE and Annoy, because they use a more advanced in-memory tree structure, we've faced a problem that we cannot modify these after they've been loaded. So this tree structure is used for faster querying, which is great, but unfortunately that gives you a problem when you try to update them. So in our case, in Jina, you need to temporarily load it as a NumPy indexer, which is the base class. Load that file from disk and perform the update and delete operations on that, then save it, and then load it with these indexers afterwards, and then they will rebuild the tree structure on the new data. And finally, expanding index sizes. The way we've implemented update and delete in order to keep things as performant as possible was to use a mask. We basically mask the rows in the matrices of data that are updated or have been deleted. But that means that the old data is still there. It's just that it's ignored. It's as if it's not there, but it's still there. It still uses up your space. So in that case, we recommend that you regularly rebuild the index. You extract all the data, you drop the rows that have been deleted, and you just index the ones that are up to date or that you're keeping in the data. And that's basically it for my part of the presentation. Any questions before we continue?
So I have a question regarding the flow YAML you are showing. So as I observed that in this flow YAML, so for example, you go to index.yaml.
Yeah.
Oh, this is flow.yaml. Sorry, flow.yaml.
Yeah.
So there is only one indexer. So does that mean let's say if we want to do the CRUD operation, especially on the update and delete, then we only need to somehow minimize the flow into indexer only. I mean, especially the delete.
So you're asking if we have another one afterwards?
I mean, yes. For example, we have the query flow, we have encoder, ranking, and so on. You know, all the kind of fancy stuff. Mm-hmm. And but when it comes to delete requests, should we just somehow either manually or automatically, minimize the flow into indexer only?
Is only needed if everything before the indexer may change the update. So if you know exactly what you want to update without crafting, is the best way.
Okay.
Anything that goes before the indexer may affect your updated document, then you will need to target and to fire the index independently.
Yeah, I mean, updated. I mean, when we talk about update requests, this kind of optimization is probably too early, right? Because we cannot guarantee whether crafter encoding affect the indexer or not. But when it comes to delete, I mean, yeah, it could be that we are doing some conditional delete, from the upflow. Yeah.
But since the delete is based on the document ID, it should not affect. Like the only thing you will have been encoding and crafting for nothing.
No, that's not. But if you have somehow encoded and crafted, and especially crafting is a segmenter and you create chunks, then these chunks might also be deleted. So this is really up for the user or for the ones that set up the flow to set them up consciously and carefully. So for now, we decided we go the way that we want to have as much flexibility as possible for the user of Jina, that they can build as powerful as possible. We have not yet decided somehow to make it somehow nicer or some safety nets in there yet, because we haven't seen where it is misused and how user would fail to use it correctly. But in principle, it's up for the user to set up their flow for delete, for update, for index, or for search, however they want it, and they have the full flexibility for now. That is up to change in the future when we see, okay, that was a bad design decision. But yeah, our first best guess is let's go for highest flexibility.
Anything
Yeah,
else?
makes sense.
Anything else? Okay, then I will stop sharing and thank you for listening to my part. Who is next in presenting?
Okay, it's Alex again. And before we move on, we've got quite a few people here. Do we have any community questions?
Yeah, so Alex, I said I'm going to present the version things. Are we going to move to that part, or like we want to have the community things first?
So on the deck in front of me, yeah, straight after CRUD, there's not much else. So if there's another section you've got you'd want to present,
yes,
I'm down for that. Yep.
Sorry, can I ask?
Yeah, sure.
Okay, yeah, I have a question about the JinaD. Is it possible to use JinaD in a Docker container on the local machine, and how would networking work in that case?
Dipanka, you want to answer this question?
Yeah, so yes, we do provide Docker containers, and I mean, within the Docker container, you can have pods inside that or flows inside that. And yeah, we still have not thoroughly tested how a Docker inside the Docker would work. But if you're using a pod inside JinaD, which is inside the Docker, it's inside the host Docker itself, then it should work as is. Yeah.
Yes, and we have one example which showcases with Docker Compose, which is our SouthPark example. If you go southpark-search/test/distributed, there we set up one of these examples, but it's not yet updated and revised before the 1.0 release, but you can, until the 1.0, there will be most probably a running version.
We have many tests of that.
Yes.
I want to make one point out there. Hey, Tadej, I think we have interacted a lot in the last days.
Yes, yes.
Yeah, regarding to the JinaD in a Docker container, the only problem you may face is if you want JinaD to spawn a container pod. In that case, there might be a lot of nuances with Docker networking to expose to start a new container from inside the JinaD container, and for the bridge networking inside Docker, that pod might end up not being reachable. So if you start a pod inside the JinaD, I would recommend to start without a container pod.
Okay, yes. And well, my worry was also, as I saw in the example that you just did on the remote machine, like when you start JinaD with Docker, network host. But I wonder how this would work if all these Docker pods are on the same machine. Can you still just do network host?
I mean, if you're running everything on the same machine, then JinaD is actually not necessary, right? Because the flow itself can orchestrate everything on its own. So JinaD is particularly useful when you have this kind of decentralized or distributed environment. You want to have, so let's say you have you have 2 laptops, or you have 3 old laptops at home, right? You can install JinaD on all these laptops, and then you have a network. You have a home network, and then you know this IP address of your old laptop is inside this home network. And then you can distribute the Jina workflow on those old laptop, right? So this is particularly useful in this kind of environment. So in larger scale, let's say you own an AWS cluster where you have 100 machines, AWS EC2 machines, and so you install JinaD on all these 100 machines, right? And then you can basically build your flow in a very scalable way. Because you can just write down, oh, I want this part to be run on this 50 machines and that part run on that 50 machines and so on. Right? And but if you run everything locally, right, then you can just use flow, right? Because flow can orchestrate very nicely whether it is whether you have a local part or container part, it can orchestrate very nicely.
Yeah, well, I was just asking this question because my idea was to orchestrate everything with Docker Compose, as I believe it's still a bit more powerful than orchestrating with a Jina flow, and then just telling Jina flow which containers it should connect the pods to.
I see. So, I mean, so in the very early version, but it's kind of like we can easily add it back. It's basically Jina flow. One of the let's say one of the major job of Jina flow is about building the network, right? So building, let's say who connects to who, right? All these dots, how can I connect all these dots together, right? So this is basically written inside the flow logic. And once the flow is built, right, we can actually output the topology into a file. So let's say a YAML file, let's say a Docker Compose file, and then hand over to Docker Compose to Docker Swarm to orchestrate that. Yeah, so this is not, I think it's there in very early version, but we actually removed that because it was out of maintenance. And we also use Docker Compose inside some integration test. And so we have some understanding of that. So it should be not difficult to add this back.
Okay, thank you. Yes, I'll think more about this. Thanks everyone for the answers.
Thank you for the question. Do we have any more at the moment? Okay, let's hand it back to Han for now.
All right, so I can, I want to present something about the, oops, where is it? Okay, so here I want to present something about the release and version identifier. So this morning I had this talk with Lucia, our product manager, and some engineering leads. But after that, I kind of like reiterate on this documentation. This is very important because we are, just 1 month away from the 1.0 release, and after that, all the versioning, semantic, all this kind of stuff has to be stabilized, right? So we have to be, we have to be really serious about releasing after 1.0, right? Okay, so basically, in short, we have 2 package management systems, PyPy and Docker Hub, right? So every time we are talking about release, then it's basically release on or in this 2 package management system, right? So this is not merged yet. This is not merged into master yet because I still want to clarify something. So this is work in progress. And so this documentation basically explains the release cycle and version identifier behind these 2 things, right? Okay. So what are the best practices that we are following? Right. So we basically follow semantic versioning, which is I strongly recommend you to read. Right. So and then the second documentation is PEP 440. Right. 440 basically describes the version identification, dependency specification from the Python community. Right. And so basically in the simplest form, Jina's version is identified by x.y.z, right? So it's a major minor patch, right? Major minor patch. So in the previous, you have seen us like we release a monthly minor release, right? And we publish a blog post and do all the campaigns on LinkedIn, Twitter, and so on, and that is a minor release. And when we talk about 1.0, right, so that is major release because it's bumping the number on the major part, right? And on daily basis, right, we publish patch release, right? So if we found something, oh, this is very serious, we have to change it, otherwise people cannot use it, and this is a patch, right? So this is a patch release. And the patch release is nevertheless, anyway will be published on every Sunday evening, right, at the 23 at 11 p.m. Right? Okay, I mean, you should already know that if you want to install latest release, then you use pip install -u Jina, and if you want to install a particular version, this is use Jina equals to x.y.z, right? And in any way, so we call this as a final release because this is something that we publish to the public, right? So we publish, this Jina C, right? This is called final release. A final release is a relative concept with respect to the developmental release, right? As described below. So this is something new. This doesn't happen in this morning. This wasn't happening this morning, so I added just a couple hours ago, but it's not really implemented. Now I want to describe how does it work. So basically, on every master merging event, we will create an early release directly from our source control, right? And this release is labeled as x.y.z.develop n, right? So which basically contains an additional suffix .dev followed by a non-negative number n. And this n number is reset on every release, on every release. And for some of you may know that in the pip command line interface, we have --pri, this pre, right? This kind of arguments. By using that, so you are basically telling pip to install the latest development release, right? Not as the latest release, but the latest development release. So in this case, it's basically the same as pip install. This one is basically the same as pip install, let's say, what is, you can ask, I think I didn't share the full screen. It's basically like a pip install the Git repository, right, on master, right? And okay, so let's look at the real example. How is everything evolved, right? So this basically describes a version epochs, which basically bumping from 0.9 to 0.9.0 to 0.9.2, right? So let's say here we are at 0.9 release, right? So this is an event. The first column is an event, and second column described, after this event happening, right? So if you do pip install Jina, so which version are you installing, right? And this is after you, if you use pip install pre Jina, right? So what version are you using? And also the after this event happening, right? So if you go to master branch, if you check init.py, what is the version written there, right? What is the version written there? So basically, if you here, for example, if I go to the if I go to Jina and okay, so if I go to Jina, I go to init. So you see there is a version written here, right? So this version is automatically bumped on every release, right? And here is also on every master merging, right? So we will look at this table. So right now we are at the first row, right? And so let's say we are at this one, right? So you see that the master version is always one version ahead of the release version. It's always one version ahead, right? So here we are at 0.9.0, and the master is already at 0.9.1.dev0, right? So this is the first developer version of, so that means it is the first developer version of 0.9.1, right? Okay, so let's say if this is merged into master, right? Nothing changed here, right? So if you install anything, it will still install 0.9.0. But if you pre-install this kind of thing, right? Pre-Jina, then it will install this one, right? It will install. Oh, sorry. I think the number should be, so this should be 1. This should be 1, and then you install 1, right? And the same, and then the master version becomes dev2, right? It stays on the same patch version, but bumping the last developer version here, right? And here, and then once this is merged, and then when you install Jina, install with a pre tag, it will install dev2, right? And then the master bumping to dev3, right? Okay, so this is about master merging. You see this. This number, the pre number, is always install the master branch version, right? And let's say here at dev4, right? We say, oh, this is we found that this 3 things somehow make a patch release, right? Because I have to solve this problem, but I cannot solve in one pull request because it's too big. So I have to split the pull request into 3 parts, and I solve it one by one. And then after all this thing is done, I think, oh, now this problem is solved. So I have to tell the community that, oh, please use this new version. So I promote this version as the minor release, right? So that's why here there is a release event happening, right? I say, oh, just publish this thing, and once it's published, then you will see that if you use regular or standard pip install, it will install 0.9.1, and immediately you'll see that this one is resetted to 0.9.2.dev0, right? Yes. So basically here, I think one of the misunderstanding previously, which happens in Action Hub Updater, is that the master version must be one minor or one patch version ahead of the release version. Right? So this needs to be taken care by all of our ecosystem, right? Like a Hub Updater, Hub Builder, and so on. Right. Okay. So this is about the Python package things. And then the second packaging system is the Docker image version. And so in the Docker image versioning, so let's first look at what are the available Docker images that we have, right? So those are the Docker images that we have. So from the smallest one, which is a Jina AI minus Jina, this latest. This one is the smallest one, is a bare bone. It contains everything that you need to run Hello World. But if you need more function features, then you may want to use Devil. And if you want to use daemons that Nan and Dipanka were talking about, you may use this image. And we also have Python 3.8 compiled version. And the 3.9 version is not yet available because Protobuf doesn't support 3.9 yet. Right? So this is the only images we have at the moment. But also we have also the corresponding master version. So this basically always corresponds to the master branch of our source code. Right. Okay, so let's look at this image versioning in detail. So this image, Docker image naming basically consists of a prefix, right? JinaAI/Jina, and this tag part. Right? The tag is basically composed of 3 parts. The first is version, the second is Python version, and the third is extra. Right? So version can take values of latest, master, x.y.z, or x.y, which is basically an alias to x.y.z. I think this is pretty, let's say, self-explanatory, right? Because yeah, latest always means the latest x.y.z, and master always corresponds to the master branch of JinaAI/Jina repository. And then the Python version 3.7, 3.8 by default, if you don't give anything here, then it is 3.7. Right? If you don't specify any Python version here, then it's always 3.7. Right? And as I said, 3.9 is in process, and we will wait until protobuf is ready. Right? Okay, then the final one is possibly more interesting is extra, right? So extra basically can take 3 kinds of value, right, at the moment. One is blank, which basically, as I said, is a bare bone. It's basically the same as pip install Jina inside the container, right? But if you want to have more functions, you can use devil. This will do pip install Jina, square bracket, devil, and a square bracket, this kind of stuff. And finally, if you want to use daemon, as Nana and Dipenka were talking about, you can add this minus daemon tag at the end. Right? So this will basically install daemon along with fluent D. But the most important thing is the entry point is changed to JinaD, not Jina anymore. So here are some examples where you can practice your understanding about the version naming conventions. So you can match, how whether your understanding is correct or the documentation is correct or not. Okay, so do you really need devil, right? I mean, so if you compare the image size, the devil image size is basically double the size of Jina itself. Well, they are all smaller than 200 megabytes. But sometimes you want to have a smaller image because it's faster to start. And so let's say you want to have a serverless environment. You want to somehow start 100 machine in just 5 seconds, right? Then the size, the communication, the size for downloading this kind of thing is actually matters, right? You want to have a faster boot size, a boot size, right? Then this size does matter. Okay, so do you really need devil here? I mean, here I summarize some special cases where you need devil images or you need pip install devil. One is you want to have a higher efficiency on async I/O and data compression. This is because in the devil we ship with a UV loop, which is a better performant async I/O event loop. And which can improve the Jina performance a lot, especially on the event handling and the network communication, right? Jina is fully asynchronized in every small details. So changing the event loop underneath, changing the event loop engine underneath actually matters a lot. Data compression means that by default, Jina does not optimize, does not compress the data when we transfer the data, right? We are fully microservice architecture, so there is always a data transfer from one to another. So by default, it doesn't compress anything. But if you install with devil, it will install a high performance compression called LZ4, and this LZ4 will basically have a very good compression without introducing too much computation overhead to the system. Enabling predefined error printing, building JinaHub extension, right? So if you want to use JinaHub, all this kind of stuff, you must install with demo, right? Or you can use pip install Jina square bracket hub. Yeah. You want to expose REST interface beyond gRPC. You want to enable log streaming aggregating via FluentD and enable Mimi type sniffing, right? Mimi type sniffing. This kind of thing you need demo, right? And so in summary, right? So when are all these images get updated, right? So you see there are some images here, but when are they updated? So on every master merge, we will update this master Jina AI minus Jina master with Python version extra, which takes combination from these values. Right? So there are 2 times 3. So every time we will build 6 images, we will update 6 images. Right? Okay. So on every x.y.z release, right? So we will update this x.y.z, this particular image, but also we will create some aliases. We will also update its corresponding aliases. So what are the aliases here? So these are the latest and x.y. All right, so those are the aliases here. So this is basically summarize the version that we have, and we will continue to, let's say, to stick to it after 1.0 release. All right. So any questions?
I have one. Will we have something like after 1.0 like stable releases? So we have releases every week and we every now and then also by hand, but will we somehow tag a release when we think, okay, that is the release when you want to use Jina currently, that is a stable one which you should use, and then somehow when after some time when we think, okay, now we have another stable release, we also mark it as stable, or how will be our
Yeah, I think that's something that we need to work out because
okay.
After 1.0, the semantic, we have to strictly let's say comply with the semantic versioning. That means every minor release means that we're still compatible. We are not introducing breaking change that is not that is a backward that is not backward compatible. And every major release means that we make a big change that all the old version cannot be used anymore. So all the flow.yamo, this kind of thing, you write before that, you cannot use that anymore. Or all the code base, all the examples that you have at the moment cannot be, it's not guaranteed to be usable in the major release, right? But I think we have to work out, from case to case, and then have this kind of experience after 1.0. But I believe having a very good version control and strictly follow the version control semantics and will basically improve not only the efficiency of the team, but also our reliability and credibility to the community, right? And so right now, for example, we have some previous example on version controlling the examples, the tutorials, the hub images that we have, and which brings us a lot of headache. And yeah, I think this is a good starter. So this documentation is a good starter. I think Cristian, Dipanka, when you work on the hub thing, so probably we also need some kind of like example or documentation like that to clarify what are the documentation, what are the image tags, and so on, and naming conventions and so on.
Thanks a lot.
Yeah. I actually have the similar question. So basically, after the 1.0, we should have kind of stable version, which we don't introduce the break changes. But so far, as we are moving fast, and iterating in a really agile way, and we have introducing breaking changes for every for basically possibly to change where we introduce break changes in possibly every manual release, and later we should have a kind of a labeling for the versioning to state that which are stable, and we introduce breaking changes only for, let's say, maybe only for the manual version, or even the major version.
Yeah, I mean, so on that part, let's stick to the semantic version, to this documentation, right? So I'm not expert on like saying which is what, but it actually, the first 3 lines actually perfectly describe what you are looking for. So my suggestion is to have this read thoroughly and have some understanding. And I think all of the questions are answered here already. Yeah. All right. So if there's no other questions, then I hand over to Alex about the community things. Yeah.
Okay. Thank you, Han. So yeah, I will share my screen and just explain a little bit about how to join the Jina community. Hang on, where are we? So yes, forgive the Photoshop. This took me all of an hour, and well, I'd say who needs Uncle Sam when you can have Uncle Han? So yeah, everybody, Jina wants you. One of the things we are working on right now is Python 3.9 support. So anyone who can lend a hand on that, get in touch, please. We also love you to submit issues via our GitHub issue tracker. Make a PR if you think there's some interesting code you can submit. Hell, if you want to work with us, we're always looking for people. So you can go to jobs.jina.ai. And yeah, we would love to hear from you on our community Slack. So to get there, you can go to slack.jina.ai. That pretty much wraps it up for today. Are there any other questions before we finish? Because we've got a lot of new people here. It'd be great to hear from you all. Okay. Oh, did someone's mic just come on? Oh, I live in hope. Okay, so finally, yeah, if you want to get in touch, our GitHub repo is the place to go. You can find out about our core search offering and our other things. If you want to build your first Jina app, you can go to hello.jina.ai. Or we also have an updated example now on our examples repo under community examples, where you can build a simple Jina app that searches sentences from Wikipedia. Join us at, as I said, Slack is slack.jina.ai. Twitter, we are JinaAI_. And yeah, great to hear from you all. Great to see you all here. Have a wonderful new year. Hey, it can't be